we're going to look at graphing two types of radical functions. We're just going to graph the square root and cube root functions. So before anything is added or subtracted or multiplied, as always, to any of the functions we looked at so far, they have a parent function for each. So if we look at the square root, and remember your square root is that index of 2 that we don't write. When you guys graph it, before anything is added or subtracted or multiplied to move it or manipulate it, it starts from that origin and sort of arcs out. So when it's starting at that origin, the domain and range for your square root function remember, domain is left to right and range is bottom to top. So your domain for this function would start at 0 and go to the right. So since 0 is actually a point, because that's where it starts, we're going to do brackets 0 and to the right, positive infinity representing the right. And then your range is starting at 0 and going up. So it too is going to be 0 to positive infinity. Now, this will change once we start to move this function. So like your function that you have here, it could move up here, or it could be on your y-axis, or it could be down here. It does eventually flip, but the parent function will stay right there for now. Now what about cube root functions? So that's with your index of 3. And it will look something like that. Now for the domain and range for these, because there's no stopping point, like there's arrows on both ends of this function, your domain and range for these is always going to be negative to positive infinity. So as soon as you see a cube root function, you can just automatically, for the domain and range, put negative to positive infinity. I understand it sort of looks like it's only going to the left and right, but it is slowly going up and it is slowly going down also. So that's the nice thing with cube root functions. You never have to figure out what the domain and range is. It just always is negative to positive infinity. So what happens if we do manipulate them and we multiply them or add something to them or whatever it may be? That's what number 1 is looking at. It wants us to graph y equals negative 3 cubed root x and the parent function, the original function, y equals cubed root of x on the same set of axes. So compare the two graphs and then state the domain and range. So let's do the parent function, which is the green one, first, just the cubed root of x. So I decided to use negative 8, 1, negative 1, 8, 0 as my values because I know that they're all perfect cubes. So remember, with cubed roots, you guys can take the value of a positive or negative. That's why I picked 1 and negative 1, 8 and negative 8. So the cube root of negative 8, if you plug negative 8 in here, the cubed root of negative 8 would be negative 2. The cube root of negative 1, what times what times what is negative 1? Is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is positive 2. So let's go ahead and plot these. So this would be your parent function. So 0, 0. 1, 1, negative 1, 1. So at this point, it just sort of looks like it's a straight line. So with the cube root function, you guys want to make sure you're getting a couple of points on here so you can sort of see the shape. And then negative 8, 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And then positive 8, positive 2. So there you guys can sort of see the shape then. Because then you can see that it's not just a straight line. So now we're going to do the function where if we multiply it by a -3. So cube root of x is still there, it's just that we're going to multiply by a -3. So we're essentially going to have the same x values. I'm still using -8, -1, because underneath here is still just an x value when we want to take the cube root. So whatever we got up here, we're just going to multiply by -3. So the cube root of -8 is -2, but multiplied by -3, we get 6. So cube root of -1 is -1 times -3 is positive. Cube root of 0, 0 times anything, that's just going to stay 0. Cube root of 1 is 1 times -3, so we get -3, and then cube root of 8 is positive 2 times -3 gets us -6. So now let's graph the 1 multiplied by -3. So 0, 0 is still on the graph, but now we've got 1, -3, -1, +3, and 8, -6. 1, 2, 3, 6. And 6. So we'll connect those dots. Maybe. So if we are looking at the gray function versus the green function, so the parent versus, and we can label them. So this is -3 cubed root x, and your original was just the cubed root of x. The domain and range is going to be the same. They're both going to be negative to positive infinity because both of them are still cubed root functions. But what's something you guys noticed about the difference? By multiplying by that 3 value, we've mentioned in the past that the value in the front, tells you a lot about what your function is going to look like. And the same thing for cube root and square root functions. Because of that 3, it's larger than 1, ignoring the negative for right now, the absolute value. 3 is larger than 1. So that's why our graph got taller, or it stretched. So the 3 stretched our function. And you guys should also notice that it's going the opposite way. That's what the negative did. So the negative flipped our function. So that a value is still very informative in the front of our function. It still tells us what's it going to look like. So we at least have some idea when we're done if we did it correctly.